And hello, welcome to a very exciting ASP.NET Community Stand-Up. I'm Jon Galloway. I'm a PM on the .NET DevDiv community team. I'm still getting used to that. We also have Dan Roth and Steve
Hi,
Sanderson.
Hello.
Hey, woo. All right. Well, so today we have kind of a neat. Steve, can you tell us? We already had people asking, like, what's Steve been working on? What's this is very exciting. What's going on? Can you tell us?
Sure. Okay. Well, yes, I'm excited to be back and to say hello to everyone. I never went away, by the way. So I'm working on mostly AI-related stuff for .NET developers. So obviously, AI is a major thing going on in the software industry at the moment. Probably will be for a long time to come. And so I'm trying to find all the ways that we can of making it as good as possible for .NET developers, not just me. There's a whole lot of people doing this. And within that in particular, I'm personally very interested in making it great for web developers, and within that, particularly very great for Blazor developers. So one of the things that we've got at the moment is this new template, which gives people hopefully a very convenient starting point if you're trying to build some sort of AI-powered app. It's not meant to cover all possible scenarios, but you can do quite a lot within this. And yeah, I'll hopefully get a chance to show you some of that as we go on today.
Awesome. Okay. Well, in terms of links, I've got a few here. First of all, just reminding people on the front of the .NET blog, we have a subject. We have it broken down. We keep these updated to kind of what the main current focus areas are. So you'll see one on here is AI. So this is a great way if you want to, say you're Maui dev or Blazor, like whatever you want to see everything about .NET Aspire, you can see those separate feeds. So here is AI. And you'll see one of the top recent posts here is the .NET AI template. So it's now available in preview. So I'm here. I'll get fancy and put us over on the right side here. But so I'm assuming we'll kind of dig a bit more into this today. But this shows you how you can install those, etc. This was fun last week. James Montemagno and I were at VS Live Las Vegas, and we showed this off in the keynote, and it was really cool, like the timing, because we were like, wait, what will be ready for VS Live, and so it was fun to play with a live chat thing on stage. And then one other post here is the AI evaluations for .NET.
Yeah. You test to make sure that your AI system is actually working as expected, that it's meeting your needs and expectations.
This is something I'm still orienting my brain around, because I always think of AI as kind of non-deterministic. Like you can set it up, you know what I mean? You throw a question in and you see what happens. It's definitely exciting in a demo, but it's also in terms of thinking about a software product where you want to make sure it's performing as expected. So yeah, I guess this is something I need to understand more. And yeah,
how you evaluate your responses, make sure they're relevant, make sure that that you have a quality assurance. Like as you make changes, does your AI chat system or whatever type of AI system you're building, does it still behave the same way? Like the evaluations library is really starting to create that DevOps story around your .NET AI development workflow.
And this is nice as an example here, the Azure DevOps plugin, as you're saying, allowing you to directly integrate that into your DevOps pipeline. So cool. All right. Well, so that's what I've got as far as links, and I think we are ready, Steve. If we want to start you up here.
Yeah.
All right. Let me I need to remove mine and add to stage. Okay, there we go.
Cool. All right. So yeah, as Jon just showed, this blog post was put out a week or so ago, which gives you some of the getting started steps for this. I'm not going to go through it all in detail, but if you do want to get started, this is the bit you're going to want to start with. Install the template now. Tells you how to do the .NET new install. Once you've done that, it'll just start showing up in Visual Studio or the VS Code C# Dev Kit, or you can use it on the console with .NET new AI Chat Web. We've actually, I think, shipped 2 updates to this just since this blog post was released. So we're moving very quickly, and we've got many more updates still to come. The version of the template that I'm going to show you today is not actually published yet. You would have to build it from source if you want to see it, but it'll be out within a week or so. What this is something to get you started if you want to build a chat type UI. Now, we're not in any way trying to say that all AI apps need to have a chat user interface, not at all. There are many other ways to use AI, many of which are easier and can be more applicable to different business processes. But chat is a really common thing that people want to do as a UI shape, and it's not easy to do. So we think, let's try and get everyone started with a really good foundation, so that you can be productive straight away from the first day and not have to spend ages figuring out all the basic details of chat. It also gives an opportunity to show off some of the cool Blazor features that can enable this sort of thing. So I am going to start by creating a project using this new template. So I'm going to go over and pick AI Chat Web App, or just as well, I could pick AI from this project types thing down here, and we'll see it shows up there as well. And when I go through there, let's give it a name. Let's call it Super App. Love names like that. And then you'll see it gives us a few options. Like, what do you want to use as your AI service provider? What do you want to use as a vector store? And we've got a few different options here for AI service provider. So you can easily change between these 2 things as you go along. The ones that we would recommend in production from this list would be Azure OpenAI or OpenAI Platform. These are both ready to work at any scale you want, though of course you do pay for those. And then these 2 options in the middle here, these are both free options. So you can run an AI model locally on your own hardware using Ollama if you want to, or if you want something that performs a lot better than that, you can use GitHub models, which is also free in development. So it's got quite tight rate limits, so you wouldn't be able to use it in production, but for local development, it's a great place to start. So we've made that the default. And then for vector store, this is a way to store information so that it can be retrieved by the AI system using semantic search. And there's a few different backend options for that. We've got this default local on disk one, just for prototyping, and then we've got a couple of real options. Quadrant is not actually, we haven't made that one available yet. That's going to be an update to the template.
Something coming, I see.
Yes, that's right. The PR hasn't even merged for that just yet. That was McKinnon, who you'll know from many different community stand-ups, has added that, and I've just taken his PR so I can show you today. All right. So what is this GitHub models thing? If you don't know about it, let me show you what that looks like. Right. So GitHub very generously, for whatever their commercial reason is making large language models available in a hosted service that you can use for free if you've got a GitHub account, which of course you all do. So you would go to this GitHub marketplace models thing. You can find some link to that somewhere, and they've got this like extensive model catalog where you can pick from many different models, all kinds of things, OpenAI ones and DeepSeek and other things. And once you've picked one of those and you choose, you can sort of experiment with it here in the web URI. But also you can then click this green button, use this model, and it'll tell you need to get a GitHub developer key, a personal access token, in order to use that. So that's what I'm going to be using here during all the demos here today. So it's all going to be totally free. And yes, let's create this project with the GitHub models as the service provider.
Are the GitHub models intended to be just used like during development and then you switch to something else in production, or are they intended also to, like, when you actually go to deploy your app for reals, that you would use those as well?
Yeah, great point. So I guess from the UI here, they're indicating that there are 2 different like flavors of this. There's the GitHub flavor of it, which is free, and that uses your own personal access token associated with your GitHub account, and that's got these tight rate limits, so you can only use it during development. And then if you want to go to prod, without having to change your code in any way, then you can use Azure AI. So I guess that's what the commercial angle is here, is once you've started using this with GitHub, the natural thing to do would be to use the Azure AI version of that. Yeah, so this template doesn't limit you to using OpenAI or Microsoft services or whatever. You can perfectly well do this with Olama, or you can do it with many different AI services. You can use Anthropic, you can use Google Gemini, all kinds of things. So yeah, right. Let's.
It's a really cool. It took a while for that to sink in for me, that it's the only change you make. So you can develop locally, rate limited, but for free. Try all the different models out, write a bunch of code, and then when you're ready to deploy, the only thing you change, no code at all you change is your API key.
Yeah,
it's magical. It's so great. So I spent my whole December like banging away on GitHub models for free, and then it's like, oh, now I'll try this on Azure AI, and it's like, okay, change.
I know when I've done this in the past, like when I've had to do when I wanted to try out some of the like OpenAI models on like Azure, like getting into Azure OpenAI and getting that set up and setting up the model and getting everything configured was a little bit. I mean, was reasonably straightforward, but it was a little bit of work. This seems like a really convenient way when you just want to play around in the development experience with using generative AI to just get going quickly without having to worry about like, okay, which subscription and which model, how much is that model going to cost, and all those types of questions. That's great.
And great if you're doing some sort of open source thing as well, where you can just publish your code and people will be able to use it as long as they've got a GitHub account. Right, so we've created this project. Now, because of the very low screen resolution I'm using for this broadcast, it's really hard to read. But when it first creates, it gives you these like setup steps, and it tells you you're going to have to put in your GitHub token, obviously, for this to work. Because I picked the GitHub option, that's what the instructions will be. If I picked a different option, it would give me different instructions. So I'm going to do that right now. I'm going to do it in a slightly different way to what it tells me in the docs. I'm going to just change this user secrets GUID because I've already configured some user secrets under a different GUID somewhere else. If you don't know what any of that means, just ignore it.
Right. I like seeing the trick there, because for my keynote last week, I showed the exact same thing off, and I think I was like, oh, I've already got one set up, but this is like your GUID
absolutely
switch.
Yep. And now I don't have to show everyone my token. Right. So yes, let's see what we've got. So if we go into Program CS, we'll see that this is a Blazor server interactive application. Blazor server is really convenient for this kind of application. It greatly simplifies a lot of things because you don't need to have APIs between the browser and the server for everything. You can see that it's setting up an OpenAI client, which is connected to this URL here. Now, this is GitHub models. I know it says ai.azure.com, but obviously you saw from before there's this obvious connection between GitHub models and Azure models, AI service there. And that's going to use this token, and then it's going to create an OpenAI client that uses that. It's going to set it up to use this particular model by default, GPT-4o Mini, and it's going to make that available to the application. So we'll go through lots more of the code in a minute, but let's just start this running first. So I'm going to Control F5 on that to build and run it, and then hopefully we'll see it starts doing something when it builds. Okay. So when that comes up, you see it starts up like a normal Blazor server application, except it's got these odd messages about processing these PDFs. Okay, and that's because we're ingesting some data that we can use within the chat system, and you can change this to other data, and I'm going to show you several ways of doing that in a minute, but let's just see what we get by default. Right, you can see it's got these two different PDFs, and in fact those two PDFs come from this data directory here inside my application. All right, so that's started up now. Let's close everything else. All right, so this is hopefully a usable chat UI that comes up, and you can, of course, customize this, or you can move it over into some other project that you're working on, whatever you like. And it's got all the kind of features you'd want in a basic AI-powered chat system. And it's ingested these two sample PDFs, such as this one about a GPS watch. And the point is that we can ask questions about our data. Now, in this case, we've got, for example, something to do with sensors that this GPS watch has. So if I ask, what sensors does the watch have, that should use this model from GitHub Models and the data that we've ingested to provide an answer. Okay, and it tells us that the watch has got all these different sensors. And quite importantly, it provides a citation at the bottom. And if I click on this citation link, you'll see it takes me into the PDF and it even highlights the specific basis for the claim that it's making there. So the user can validate that this is all actually true. All right, so that's a really straightforward way to get started. Let's have a look at a little bit more of the code. Now, like I said, this is a Blazor server application, and we've got this chat directory over here with all these different chat-related components. Now, I know it looks like a lot of code when you first see it. It kind of is a lot of code. Maybe there's like 300 lines of code across all these things. I'm not sure. But that's because it's not trivial to build a whole chat UI that deals with, streaming the data, providing suggested user follow-ups, providing citations, doing markdown formatting, loads of other things that you would want in this sort of application. And if we look at the actual code inside here, hopefully it'll be reasonably intelligible. So this is the overall shape of the UI. We've got this header up at the top, which has got the reset conversation button in it. We then got the list of all the messages in the conversation, which does things like keeping track of whether there's a response in progress and things like that. Then at the bottom, we've got the suggestions that the user can follow up with. So that's here, like what sensor is most useful and things like that. We've got the actual input box the user types in, and we've got this survey prompt where we'd like you to give us your feedback. Now, I'm just going to clean this up a little bit. Let's get rid of that survey prompt. We don't need it in this demo. I also don't need this sample content that shows up when you first arrive on the page. So let's just get rid of that as well. So it all just starts blank. All right, and then below that, we've got the system prompt that's being provided to the AI system that's saying, you can give it whatever instructions you want. In this case, it's you answer questions about information you retrieve. Don't answer questions about anything else. And we tell it how we want it to give citations, tell it that we want it to give short quotations from the document, that kind of thing. And of course, that I can change that if I want to. Let's say I want to change it so that I really want to tell it to only use the information that it retrieves from my data. So I'm going to add this extra bit of prompt here that says only supply information based on search results, not based on your existing knowledge. And we'll see if it actually obeys that in a minute. Okay, what other code have we got? Well, we've got, this is the code that runs when the user enters a message. Okay, so again, I know it's quite a lot of code, but hopefully it will make sense when we go through it. So when the user posts a message, we'll add it to the list of messages. We'll clear out the current input, but refocus it. We'll then send the message to the AI backend and get the response coming back streaming. And every time there's an update on that streaming stream, we'll add it into our model so it shows up in the UI. And then finally, when it's finished, we will reset the UI back into a sort of like not in progress state. And that's most of the code that's in here. If we look down here, you see there's a couple of other things for what happens if we need to cancel a response that's in progress, and what happens if the user clicks the reset conversation button. And then the only other thing in here is the tool that we're making available to it. So in order to search the data that we've ingested, we've added this C# function called search async that we're making available to AI, and that can pass in any search phrase it wants, and we'll do a search for it using semantic search through the data that's been ingested, and then that becomes available for the AI to answer based on. So this is a pattern called retrieval augmented generation. Now, I imagine Jon and Dan, you are familiar with that pattern. Is that right? Do you think people will know about that, or anything else you think we should explain?
I am familiar with it, although I'm guessing some people are new.
Yeah,
to
it'd be worth. We've got some people on the chat saying they're beginners. So yeah, it'd be good to explain the pattern.
I still remember when I first learned just about the concept of how you can basically advertise to the AI model that, hey, by the way, I've got this tool locally as part of my app, my code. If you'd like to call it, just let me know. This is kind of what its structure looks like. These are the parameters, what the method name is. Let me know if you want to call this thing. And then the AI models know how to deal with that. And they can ask you like, yeah, please call your search async tool with these particular parameters that are relevant to the conversation we're having. And I remember when I found out about that, I was like, oh, like this is now how you take AI systems and give them superpowers. Like you give them ability to do things that are specific to your app, specific to your scenarios. In this case, it's using it to get access to data, right? Like to information that you want it to know about.
That's right. Yeah. If we didn't have this, then its responses would just be based only on information that's been learned in the model itself. So in the weights that have been trained into it by OpenAI or Anthropic or whoever else. And that would know about a bunch of general knowledge stuff, but it wouldn't know about your business data. It wouldn't know about that GPS watch that I had because it's a fictional product. So yeah, by advertising a function that it can call to get more information, we can augment that model with any data that we want or any other capabilities that we want. So to see that really clearly, let's put a breakpoint in here and let's see if we can see it actually call our function. Now, for people who, one of the key APIs behind all this is this thing called iChat client. Now, this comes from a new .NET library called Microsoft Extensions AI. That's something I've been working on over the last 6 months. And we want that to be a standard representation for AI services for .NET. So in the same way we've got a standard iLogger or an iService provider, many other standard representations for things in .NET, we want to have iChat client as a standard representation for a language model service that you can call with a chat kind of pattern. It doesn't mean your UI has to be a chat shape. It means that the way that you call the AI system is a chat protocol, which basically they all are. So you can use that whether or not your UI is actually a chat. Does that make sense?
Yeah.
To me, I don't see any questions about it yet in the chat, in the
All
human
right.
chat.
Yes, the chat about the chat, which is not always a chat. Okay, so when you've got your iChat client, you can call APIs in it like get streaming response, and we pass in all the messages in our conversation and any other options that we want to make available. And within our options, you can see up here we've added a tool called Search Async, and so that is allowing the AI system to do callbacks into Search Async. And it will decide when it wants to do that based on the way you've prompted it. And I've prompted it, if you remember, to say, I really want you to get all the information you can from the search results, not based on your existing knowledge. So it'll really try to call this Search Async to get whatever information.
No, it won't. Like, it's not like the AI system on in GitHub or in Azure AI has like access to that code directly. It's not like
No.
it's somehow calling some API endpoint on the web or anything. It's
it's
basically just sending a response back to you in its generated response, like, hey, I would like you, code, whoever you are, to please call this API. And that chat abstractions that we have as part of the Microsoft Extensions AI system knows how to then see that response and then make the tool call on its behalf. And you could even have like a little user interaction there that says, hey, the AI wants to call this tool. Is that okay? They can say yes or no, those types of things.
Yeah, so that behavior is all baked into this call here. When we say get streaming response, we're first sending the conversation up to the AI service, and it might reply initially to say, I want you to do a search for me. And then that automatically calls our search method and it gets the return value. Then it gives the AI another chance to answer based on that result and so on. And eventually the response comes back. And that's all happening inside this one async call. So you don't actually see that. You don't have to deal with implementing all of that interactions. It's baked into the Microsoft Extensions AI library. So anyway, let's see if we can see it call our search async function. Remember, I told it, I don't want you to use your existing knowledge, only use the search results. So if I ask it a question like, what's 1 + 1? Now, normally it would know the answer to that, but hopefully this time it will try to do a search. So you can see it's actually called my search async function, passing in the search term of 1 + 1. So it's now going to search our documents to try and find an answer to the question of what's 1 + 1. I don't know whether it will find an answer to that in here. Okay, it's citing an example of the number 2 inside this PDF. So great, good job.
I mean,
or you have a table in your PDF files of every addition problem.
Yeah,
just looking it up.
We should, right? Why don't you ingest a document that's got all maths?
True,
okay.
complete.
All right, cool. So that's the super basics of the retrieval augmented base generation pattern and how you can expose something like a search function. Now, remember, we've just ingested some sample data here, these 2 PDFs, which have been provided inside the template. But I want to show you a few things about other ways you can get data. And the most basic one is to just swap out these PDFs with your own ones. So let's say I delete this GPS watch from here, and I'm going to put in a few others, right? So I'm going to put in these 3 different weirdly named PDFs. Right now, these are all academic research papers that have been published in the last 12 hours, right? I've got them from the archive website. And because they're all like literally like just uploaded in the last few hours, obviously the AI system doesn't know about them yet, but we'll still be able to retrieve information from them because we're going to ingest this into our system. These are all stuff to do with AI research, like LLM-powered navigations and AI agents. Okay, so we're going to see that we can ingest that content and then retrieve information about them. So I'm just going to restart my application now. And when that comes up, you'll see, firstly, it's detected that GPS watch thing is now gone. So it's removing the data for that. And it's detected that these 3 new files have become available. So it's ingesting the contents of those. And I'll show you how that works in a second. And then the app comes back up. All right, so now I can ask it some questions. Now, I happen to know that one of those PDFs I ingested says something about Bergamo Airport, okay, which is, I think, a city in Italy, but I don't know for sure. Right, let's have, how is Bergamo Airport organized? Let's say shaped, in fact. All right, so that, remember, we've told it not to use any existing knowledge that it has, but to only use the data that we've ingested. And it says Bergamo Airport as a large single corridor, okay? And it's providing a citation to one of these PDFs that I've just ingested. And if I click on that, you'll see that it says something is similar to Bergamo Airport and has a structure with a large single corridor with shops. Wow. So that's the basis of it making this claim. And we can see that that's actually correct. Some of the other documents that I've ingested have got stuff to do with AI. So I'll ask it about Microsoft's AI. So what does Copilot do? Okay. We'll see if there's something in.
What does it not do, Steve?
Oh, yeah, that's the right question, isn't it? Okay, so it's found that Copilot does all this stuff, collaboration, task management, blah, blah, blah. And once again, I can click on my citation and it takes me into this thing about Microsoft 2024, describes how Copilot helps with creative projects and other things. All right, so that's the simplest way of getting your own custom data into it, is to just replace the PDFs with other PDFs. Okay. Now we'll talk about how the ingestion process works on the inside in some detail later on, but let's add some other capabilities to our application. So just in the same way that you can add a function for searching data, we could add functions to have any other capabilities at all. So let's say I want to do one of the most predictable things that you do with these things, which is to get a weather report. So let's say, like, what's the temperature? Okay. It's going to try and search for current temperature because I've told it to always use search, and none of the documents tell us what the current temperature are, which is not surprising because you wouldn't put that sort of information in a PDF. Now, I want it to be able to look up the current temperature. So what I'm going to do is add another C# function down here called get temperature. Okay, and it's going to take in a latitude and a longitude, and it's going to use this JSON web service to get the temperature for a certain latitude and longitude and parse that back in this way. Now, the user probably doesn't want to type in a latitude and longitude. They probably just want to type in the name of a city or something. So I'm going to add another function up here called get latitude longitude, which takes in a location and it uses another web service to get the geographic coordinates of that location. And so we're going to check, is the AI system smart enough to chain these two function calls together to answer the user's query? So let's put a couple of breakpoints and these things. And I have to actually expose these methods to the AI system. It can't just call them any of my code unless I add AI functions for them. And AI detects that I want to do that, and it fills that in for me. Thank you, Copilot. Let's press F5 to start that running again. And let's see if it will call my C# functions now. So let's say, what's the temperature? And it knows the method signature and that it's going to require a location. So it asks me now, what location do you want? And I'm going to put Bristol, which is where I am. And I'll press enter. And then we should see over here that it's hit the breakpoint and it's decided to call get latitude longitude first. It can call any functions in any order. It's decided, using its AI smartness, to call get latitude longitude, passing in this location Bristol, and that's going to get some coordinates. And then it's calling get temperature, and it's passing in the latitude, longitude that it got from the previous result to look up the current temperature. And then when we get back into the UI, the temperature in Bristol is 12 degrees C. I'm just going to check. Is that right? It's actually not. It's 11 degrees, but maybe that was the, I don't know, maybe my watch is wrong. But anyway, it's more or less right.
Give it a little bit of buffer on its
Yeah.
margin.
All right. So so that is how another way that we can extend the system, or you can give it whatever capabilities you can write C# code to do. All right. Things making sense so far? Any questions?
Wire it up to your financial stuff and say, like, please optimize my stock portfolio for me. Like,
yeah, why not?
Don't do that. That was at least not yet.
Wow.
Cool. All right. Any questions that we want to ask, or should we talk about some custom?
There's been a bunch of questions.
Yeah. Right.
So someone asked about like the sources of the data that the current RAG system supports. Like you showed how it can use like vector databases or just the file system. Someone asked if it could pull data out of SQL Server.
Great. Let us talk about custom ingestion. So you can pull data from anywhere you like. And I'm going to show you an example. Right. So how does the ingestion process work right now? Or what we're even trying to do with this ingestion? So first thing I want everyone to understand is this is not meant to be the ultimate data ingestion framework. Okay. Whether or not this meets your needs is not, like, it's not our goal to cover every possible thing. Yeah, this is a template. It's a starting point, and the intention is that you will build your own code, and maybe you can extend these patterns, or maybe you need to throw it away and create a different ingestion system. That's up to you. We're kind of looking for feedback on that as we go. The way it works in this application is in Program CS, when it's starting up, it calls this data ingester, ingest data async, and we specify what source we want it to ingest stuff from. And within the template, we've got this one example called PDF directory source. Inside there, you'll see the implementation. And as you can guess from the name, it looks in a certain directory and finds PDFs and ingests them. And the logic in here is basically stuff to do with parsing PDFs. All right, but I'm not going to get into that too much. Let's understand how this works in more detail by creating our own custom ingestion source right now. So let's say that I want it to be able to answer questions about how to do AI programming with .NET. All right, and I want a good up-to-date source of information about that. And what I'm going to use is this workshop that some genius has created and put on GitHub, which I'm now subtly advertising to you. So if you want to learn about doing AI programming with .NET, you can go to this .NET AI workshop, and it will give you this really nice step-by-step process going through all these different AI-related topics, and it's got full tutorials and cool examples and things like that. It's actually brilliant, in my opinion, although maybe I'm slightly biased. And if we go into the instructions for there, you'll see we've got all these different markdown files that explain how to use these up-to-date libraries from your .NET code. And what I want to do now is create a custom ingestion system that fetches all these markdown files from GitHub and ingests them. And so that'll give you a general idea of how you can do this with a custom data source. All right. So what I'm going to do is I'm going to create in this ingestion folder here a new item, and I'm going to call it GitHub Markdown Source. All right. Could call it whatever I want, obviously. And I'm going to implement this interface called iIngestion Source. Now, iIngestion Source is not some sort of official thing, okay? It's just an interface within this project template. So you can change it, you can extend it, you can throw it away, whatever you want, all right? And to implement iIngestion Source, you have to provide these capabilities. You have to provide a source ID, which is just any unique string to distinguish it from other sources. So let's say GitHub Markdown. Could be any string, doesn't matter. And then we've got to have the ability to figure out what stuff has changed since last time we did ingestion, because the idea is that this is an incremental ingestion mechanism. So the first thing it's going to do is going to call get new or modified documents, and it'll tell you what data it's already got from the previous time it ingested stuff, and it's up to you to provide a list of what's new or modified. It will also call get deleted documents to find out what's deleted. In this case, I'm not going to deal with that at all. Let's just pretend that nothing ever gets deleted. So I'm just going to return an empty set every time. So nothing ever gets deleted. All right. And then finally, it'll ask for us to provide a set of records for whatever stuff has been new or modified. And you'll understand that more when I write some code for it. So let's start with this get new or modified documents. Well, I'm going to need to have some way of going to GitHub to get contents from a certain repo, right? So what I want to do is first add a reference to a .NET NuGet package that can fetch stuff from GitHub. So I'm going to go into manage NuGet packages, and I'm going to search for this thing called OctoKit, which is the most widely used one. And that should be here. Right, so let's install that. Okay, and that can fetch stuff from GitHub. And then I'm going to use it here. So I'm going to add some constructor parameters here. My constructor parameters are going to be a GitHub client that can fetch stuff from GitHub. And then I want to know which repo, which owner, which repo, and what path within that repo we're going to ingest content from. Okay, so let's add some code into program CS that's going to actually use that. So as well as ingesting PDFs, I'm also going to ingest stuff from my GitHub Markdown source. Okay, and I'm going to need to pass in a GitHub client for that. So let's just construct a GitHub client and use the same API key that we were using for AI a minute ago. And then we'll pass in our GitHub client here, as well as the other parameters that it needs. So because I want to fetch stuff from that .NET AI workshop repo, I'll pass in the owner, the repo name, and the path within it that we want to pull content from. Okay, so now we need to start implementing stuff. Get new or modified documents. All right, how are we going to do that? Well, first thing I'm going to do is I'm going to use OctoKit to get all the content items within that particular path. So let's just mark this method as async. Okay, so I'm going to GitHub and I'm saying within that repository, get all the contents. Is that right? That's right. Okay. Right. So let's just check if that actually works. I'm going to need, actually, let's move on. Let's then process all of that stuff. So for each of the things that comes back from there, I'm going to check, is it a markdown file? If it is, then I'm going to do something with it. All right. I'm going to have to just return these results as well for that to be a valid thing. Right. Let's just set a breakpoint on here and see if it calls this method and if we successfully manage to pull a list of all the contents from that GitHub repo. Right, so when it starts up, it should try to ingest from the source. It does, and we can see that the all contents list contains all of these different markdown files like we expect. All right, so now we're going to need to do something with that. So the first thing I want to do is check if we already know about this file. Right, so we're going to check our existing documents and see if we already know about it or not. So we're going to get the existing documents and we're going to search for anything whose ID matches the path of this file already. Okay. And if nothing matches, then this is new. So we're going to need to add a new ingested document. And I think AI has correctly worked out how to do that almost, except I want the version to be the SHA hash of that particular file. Okay. So, and then we would need to add that. So we'd say results.add. Okay, so that will, that will deal with newly added content. Okay, now what about content that we already know about? Let's check if it's changed. Has it changed? Okay, so what we'll do is check. Oh, that basically works correctly already. So we'll check if the existing file version is different from the current version. If it is different, then we're going to update our version of it and we'll add it to the list of things that we need to re-ingest. All right. So that should correctly process all the contents of the repo and return the list of new and modified things. And then the ingestion system will ask us to create records for each of the stuff that's been modified. So let's see if that works. Let's just put a breakpoint here where we return results and we'll see if we get a list of ingested documents that are new. So we should hit our breakpoint. And you can see that all 11 of those things are new to us right now. And we've got the version for each of them. Okay. And then it should call this other thing, create records for document, and it will call that for each of the documents in turn. So it's starting with this number one build a quiz app, which right now would just throw. So we'll stop debugging and we'll put in some implementation. All right. So the implementation.
While you're doing that, there's kind of an interesting question that's right on this. Someone's saying Andy's saying if you had lots of markdown files with lots of information, that would use up a lot of tokens since it has to read through the data. So I guess two things. One is you're being really smart about only processing things that have changed.
Yep.
So you're not doing extra work. But can you get an idea of like how many tokens you're using or, how do you track that here?
Yeah. So you can. So there are APIs. I don't actually have that code in this demo, but there are APIs that you can use to tokenize the text and check how big it's going to be. You can also use techniques like retrying if you hit a rate limit. And you can also, you probably wouldn't in a real production system always want to do the ingestion just when your app is starting up. That's what this template does. But in a more realistic scenario, you've probably got something in the real world that triggers an update. So you might have some sort of content management system that will call a webhook when some content has changed or something like that. Or maybe you running something on a regular basis from a background job or whatever. Now, we can't do all that stuff in this template because we're trying to keep it intelligible. But this gives you a sense of how you can get started. And then it's up to you to figure out how to adapt that in a realistic scenario for whatever your business requirements are.
Although I think that might be like that question. I'm not sure if that question was about the ingestion process or if it was about the actual query itself. Like you can imagine naively that the way you do a query based off some data is you take those PDF files and stick them into your prompt along with your question and say, here's a whole bunch of data and here's the thing I want to know about it. Let me know. And that would obviously use a ton of tokens.
Yeah.
But that's not actually how this system works. Like the ingestion process, we're about to, I think, to get to the part where you're going to take those documents and kind of shred them, like like slice them up into a database and give little semantic meaning to each piece so that you can intelligently query.
That's absolutely true.
So when you're actually sending the prompt about this information, you'll only then you'll allow the AI to get just the piece of information it needs in order to answer the question, and that was what will go into the prompt, and they'll keep the prompt smaller. In the ingestion process, you also will use some AI, I assume, to digest the documents to figure out what their semantics are. And there's a question about keeping that cheap, and that's just making sure, I guess, that you don't duplicate the processing of things that you've already processed before. Hence, all this checking to see is this a new piece of information or not? Is that right?
That's absolutely right. Yes, and in fact, that will be clearer when we actually add the next bit of code. So I'm just going to dump in quite a bit of code. So what? Oh, I need to make that async. All right. So what does it mean to actually create records for a document? In this case, what we're doing is we're using our GitHub client again to get the actual raw content. That comes back as an array of bytes. So first we have to convert that into a .NET string like this. That's fairly familiar. And then we want to split it up into lots of small pieces because just like you explained there, we don't want to put complete documents into our vector store because that won't perform very well when it comes to semantic search, and it would mean that you're using tons of tokens every time you try to include that in the context that you're searching through. So what we're doing here is we're taking that string and splitting it up into approximately 400 character chunks on natural boundaries. So this is a helper, this text chunker that's provided by semantic kernel. I'm not really using semantic kernel here, but I'm just using this one utility from it that splits things up in a nice way, roughly every 400 characters in this case. And then I'm going to construct embeddings of it. An embedding, for anyone who doesn't know, is something that an AI system can create. So you provide some content like a string or an image or whatever, and an embedding of that is a vector, an array of numbers that represents the meaning of it. And we can use that for semantic search. So there's loads more content you can read about if you want to know about that. For example, you can go to this .NET AI workshop and go into section 2 embeddings, and you can learn all about how semantic search works. But we're just kind of using that here. Now, there's an annoying issue where I have to acknowledge that this API is experimental. Otherwise, it'll give me a compiler error. So let's suppress that warning. Okay. So yes, I know it's an experimental API. Let's just put the warning up here. All right. And then we're returning a chunk for each of them. So let's just check that works, shall we? So let's put a breakpoint on there and we'll see if it actually fetches the content, splits it up into chunks, and then adds it into our vector database. All right. So for the first document, we do a request and we get back these 15,000 bytes. We'll then convert that into a .NET string here. So you can see it's got this like welcome to the workshop stuff. We'll then split that up into chunks. In this case, it happens to produce 16 chunks that are each about 400 characters, and they're split on paragraph boundaries usually. And then we're going to use an embedding model to get a set of embeddings for each of those. And that represents the meaning of them. And then we'll add that into our vector store. So if I run that or allow it to keep running, it's now going to process all of these different documents and add them into its store. And then hopefully I'll be able to start asking the chat system about it. So that comes back up, and I can now ask it some questions like what AI backends does Microsoft.extensions.ai support? Okay, and that will now be able to use all the data that I have ingested. Let's see. It comes back with, it supports several backends, including these 3. That's true. It actually supports about 20 different backends. So that's, but these are the only ones that are actually mentioned in those documents. So that's the only information it can use. Now you'll notice it's not giving me a citation link in this case. And that's because if we look at the Blazor code that defines how citations are rendered, you see it's this component here that's displaying this bit of markup, and it needs a URL in order to provide a link. And the logic in here only works with PDFs right now because it wants to use this PDF viewer. So I'm going to put in a little bit more logic to say, if it's not a PDF, but it is in fact a markdown file, then provide this link. Now, obviously, it's a bit rubbish to hard code that URL, but I'm just trying to keep things simple for this demo. So let's just check that that actually works, shall we? So let's take that question. I'll just put that on my clipboard so I can use it again. Restart the application.
See, even Steve Sanderson doesn't let perfection be the enemy of working code.
No, indeed. Right, so it's going to do its search again, and this time you'll see it's provided a nice citation to that particular file. We can get in there and we can see that, you know, it is in fact talking about these different things. We can also use this to generate code for us as well, which is kind of nice. So I could say something like the following. Give me an example of a C# chat loop that has an OLAMA backend, and that's going to use all this instructions from that workshop here, and it's going to provide a nice C# example here that use the Microsoft Extensions AI libraries here. It's actually taken this example verbatim from one of the documents in here. So you can see it's a little while loop that reads input from the user, adds the message to a conversation, gets the response from the iChat client, adds it to the list, and writes it out to the console. And it's provided our citation here with this simple chat loop. Okay, so that's clearly working quite nicely. All right.
Ooh.
Let's take this up to the next level now. So far, you remember when I created this in the first place, it asked me what vector store I wanted to use, and I said local on disk. All right, because that's good for getting started with. But you do not want to do that in production, okay? Because what that's doing is it's got this built class here called JSON vector store, and it's just taking all the vector vector data, and it's just JSON serializing it all into one giant JSON document on disk, which is unbelievably inefficient. Do not do that in production, but it is quite convenient for getting started with. I want to use a real vector database now so that I can scale up to arbitrarily large amounts of data. And the thing that's going to make that really easy for me is our good friend Aspire. So let's see how straightforward it is to use Aspire to add a real vector database into this. So the first thing I'm going to do is say add .NET Aspire orchestrator support. Now, I could have picked this from the beginning. When I created the project, I could have said, just give me a quadrant database, and it would have made me an Aspire project. But I didn't, so I'm having to add it myself now. So I'm saying add an Aspire orchestrator, and that does that. Okay, and I'm going to be able to just Control F5 on there, and it should continue to behave like it did before, except now it's going to have an Aspire dashboard in front of all that. So when that eventually comes up, okay, I've got my Aspire dashboard, and if I go into my application, it's here, and you know it's going to behave the same way as before. Okay, but I want to use a quadrant vector database. Now, there are many vector databases available. Quadrant is one of them. It's quite easy to get started with, works really nicely with Docker and Aspire. So that's the one I'm going to use. So what I have to do is go to add .NET Aspire package, and I'm going to search for quadrant like that. And it knows, oh, better pick the correct package source. And it knows I want the hosting package here. So I'm going to install that. I'll accept that. Okay, so that's added the quadrant reference. I'm just going to update my app host to the corresponding version of Aspire as well. All right, and now I can say something like the following. I want to define a variable called quadrant, and I'm going to add an instance of a quadrant resource. I'll give it this name, VectorDB, and I want it to be persistent, so it doesn't lose all its data every time I restart my application. So that's what with data volume does. It allows it to track data across restarts. And then I'm going to add a reference to Quadrant in my web project. Okay, so now I can consume and use a Quadrant vector database. So to do that, I'm going to add a reference to the Quadrant client library inside my web project here. So once again, I'll search for Quadrant like that, and it knows that I want the client package this time because I'm in the client project. So it adds that. And also, just to skip ahead because we're running low on time, I'm going to add this other helper, this Microsoft Semantic Kernel Quadrant connector. Once again, I'm not really using Semantic Kernel in full here. I'm just using this connector that's going to make it easy for me to actually use Quadrant within my application. All right, so now I've done that, I can add a reference I can add a Quadrant service to my DI config. And I do that with some simple command like builder.addQuadrantClient and have the name that matches up with what Aspire is passing in. And then finally, I want to register an instance of a vector store. So you'll see before I was using this horrible JSON vector store and registering that as the vector store. I'm going to get rid of that now. And instead of that, I'm now going to say, I want to register a vector store, which is Quadrant. Okay. And that should be all I have to do to make this thing really work. So let's just reset the state of things by closing this down, deleting the stuff that we don't need, and then restart this application inside Aspire. And hopefully when it comes up this time, we'll see that we have a real Quadrant database and it will re-ingest the contents into it because it will see that none of it is there right now. And then we would be able to work with much larger volumes of data. Okay, so in Aspire, you can see it's got the Quadrant vector database there now. And if we look in the console logs for our application, you can see it started processing all this stuff again. So it's going to go through all of these different data sources and ingest all of that. And we can check that it's been ingested. If we go over here, we can actually open up the Quadrant dashboard like this. It wants to have an API key. So Aspire has passed an API key. I hope this is recorded because obviously no one's going to be able to keep track of what I'm doing at this speed. But you can go back through the recording and see what I'm doing.
We watch it at half speed and be like, wait, what did he do?
Aspire is setting up this API key for security and passing that into Quadrant. And Quadrant wants me to give it the API key in order to be allowed to see the dashboard. So I'm going to paste that in. All right. And you can see that we've ingested 600 different points into our Quadrant data store here. And if we can go in there, we can see that we've got all these things that are coming from these PDFs or from the GitHub source like that. And the funnest thing we can do is visualize it. So I can go over here to this visualize UI and I can press the run button or control enter, and you'll see it depicts all the different points that have been ingested. In fact, we've got more than 500 points. So let's show more of them. And we can even start to see how they get clustered. So you'll notice that each of these points has got metadata, including a file name on it. So I could say that when we visualize this, we're going to use color by file name. Okay, I'll try that again now. And apologies to anyone who is colorblind, because this is not going to work for you. So I fully appreciate this is not a fully accessible demo. I'm sorry if that's the case for you. But I will just explain that we've got different colored groups of points on the screen right now. So around here, we've got a load of orange points, and these are all stuff that seem to be to do with some academic document about AI query refinement. So that's one of the things I've ingested. We've got another big cluster of red points down here, which is from another academic paper. Over here, we've got a cluster of blue points, which is from something to do with navigation with AI. We've got a cluster of green points that have got to do with an emergency survival kit. And we've got a cluster of different colored points up here that refer to different stuff that's come from the workshop. So the point that I'm making here is that a vector database, when it works with your embeddings, is effectively understanding the kind of landscape of all the information you fed into it and organizing it into different thematic groups. You can see what the clusters of them are if you're trying to understand what's in your document. And that's how the semantic search works and how it's able to find documents that are relevant. So let's just check it still works. So write me iChat client code to tell a joke. So let's just check it does have access to this information that I've ingested from the workshop there. Should be querying our vector database. And in this case, you can see that there's nothing in the workshop that's specifically about telling jokes, but it does have access to, well, it's a very sort of limited example, but anyway, you can see it does still have access to the same information. Okay, right. So we are, I think, pretty short on time. That I've got other cool stuff that I can show, but I don't want to be overdoing the timings. So I guess I'll ask our hosts now, what would you want to do? Do you want to answer any questions? Do you just want to finish? Do you want me to show some other cool thing? What's good from here?
Gosh.
Yes. I mean, do you have time, Steve? Like, how much time do you have?
Yeah. I have time.
You want to show more stuff? I'm sure we'd be happy to see more stuff. There are a bunch of questions.
We could kind of rip through a few questions quickly. I think there's some quick ones that we could get to. Let's try some questions and then get back to some more stuff. Will there be a Blazor app version? I think they're saying WASM, not Blazor server.
Yeah.
Right. We are not planning to ship a template like that. So we are working super hard and super fast to get out as many cool things as we can. And we're trying to do a broad range of things. So we've got our example of a Blazor server application. We think that probably the Blazor community can figure out how to convert a Blazor server app into a Blazor WebAssembly app. If eventually there's enough demand for that, then maybe we'll add that. But it's just not on our backlog right now. We've got so many other things to do.
You mentioned earlier how Blazor server is really great for these AI applications. I think it's worth mentioning why. Like with Blazor server, you have this natural real-time pipe between the browser and the server. So when you're often with these chat apps, you're trying to stream responses from the generative AI system to your end users so they can see the responses as they come in. Blazor server just makes that really easy, and it keeps all the logic that's actually interacting with the AI system, where you have your keys and stuff for talking to it on the server at the same time. So it's really kind of a nice setup for building these types of apps. If you wanted to do it with Blazor WebAssembly yourself, then now you have this work of setting up the proper API endpoints that know how to stream to the client, and so that you can then handle the AI access from the server, presumably, and then stream that down to your user, and you'll have to process that yourself. Blazor server just makes that kind of trivial.
Cool. Let me see. A few people asking about your Visual Studio UI, like what is your theme and all that. I only bring it up because several people are like, we love the theme.
It's the default dark theme. I'm not sure what people think is different.
Maybe it's that it's in preview, that you're running preview, and I don't know.
I don't know.
I'm on preview as well, and I don't get the rounded corners either. So that must be a
yeah, there was at some point in the past they said like we've got a new UI design thing that you can go into the settings and enable, and I did it, and I can't remember what setting it is, but
I've got that turned on too, and I forget what I did. It's one of the settings.
Yeah.
Cool.
Search the quick search thing in Visual Studio for the feature, and you'll probably find it that way.
There you go. Question about templates for F#.
Same, no plans. So for the same reason, like it would be nice, but that's not going to get to the top of our backlog anytime soon. We've got so many other things we want to do.
Okay. One more question, and then let you get to more demos here. Can I add MCP, Model Context Protocol services, to this as well? I'm partly bringing this up because you're going to teach me about MCP.
Would you like a demo of doing that?
Is that a good one? Good transition. Do you have an MCP demo?
I do.
Oh my goodness. What? Okay, hold on. Before we get to that, there were a couple other questions that I also wanted.
Go for
it. There was ones about the people asking questions about the privacy policies for the models and so forth. Like, does GitHub models going to use your data that you're sending as part of your development to train the models? I know with Azure, the AI services, I believe that the data policy there is no, like we don't use it for any of that stuff. Do you know for GitHub models if it's the same policy?
I don't know anything about that. Sorry.
You'll probably have to check the data policy on the GitHub Models offering. But for Azure AI, when you go into production, absolutely not. By default, from what I understand, check the actual policy statement and to see what it says. But from what I understand, we don't use your data for any of that.
There's like a trust center thing for GitHub, and I'll get the link for that and I'll paste it in the chat for that specifically.
And then for that SQL Server question that we had earlier, so then I think the answer to that one was you can write a custom ingester that would go to SQL Server and ingest the data from it. Doesn't the SQL Server have its own vector store capabilities that you could potentially use as well?
Yes, it does. And so this concept of like doing a one-time ingestion into a vector database, this is not the only way it could work, right? There are multiple other things you could do. For example, let's say that you might not even need an ingestion process at all. Maybe you've got some other system completely independent from your web app here that in some way causes a vector database to be updated over time. At that point, you just query it. Like, you don't have to deal with ingestion at that point. And an example of that is maybe you're using something like Azure AI Search. Now, that's got its own ingestion mechanism and all kinds of libraries around that and tons of infrastructure and ecosystem around how to populate your Azure AI Search database. If you're using that, you don't have to deal with any of that in your application code. You're just going to query the database. And then finally, it could be that the data source is something like just a traditional SQL database that isn't even semantic search. At that point, you could create an AI function in the same way that I did for search async or get weather or whatever, that just does a traditional database lookup to fetch some data based on a search term or something.
Yeah. Okay. Cool. Okay. Let's see some MCP, some model context protocol stuff. What's that all about?
Well, just before we get to that, let me just finish off the stuff to do with Aspire, because one of the key bits of value of using Aspire is that you have this observability of what's going on. Now, right now in my application, I don't really have any useful observability. If I go into tracers, I just see this sort of like generic list of stuff. And if I go into metrics, there's nothing to do with AI stuff in there. But it's very, very straightforward to add that. So one of the nice things about this set of libraries in Microsoft Extensions AI is that we support middleware for doing all kinds of different things with AI services. And one of them is use OpenTelemetry. So that's just baked in. In fact, that's turned on by default if you use the Aspire version of the template. And then that's now going to publish OpenTelemetry data to do with our chat interactions. And we can tell Aspire that we want it to surface this. So I could go to the bit that configures all this stuff down here where we're setting up add OpenTelemetry. And I could say, with the metrics, I want to add everything that comes out of Microsoft Extensions AI. And for the tracing, I also want to add everything that comes out of Microsoft Extensions AI. Now, we got the word experimental in there because the actual spec around the OTel data that is produced, that's a third-party spec that we're conforming to, and that's evolving over time. So that will change. And so we've put this word experimental in just so that you know that that's going to change over time, and we're not promising that whatever shape of data comes out today is always going to be the case. Right, so restarting everything, and hopefully we'll be able to see some useful telemetry coming out of the system now. Just wait for that to come back up. All right, and it does come back up. Close everything else. Go back into my project, and I'll get it to do something like, what's the weather? Right, and so you should remember that that's going through that whole system that we did before. Now, if I go into tracers now, we should see various bits of things that can show us more about what's been going on. And it's actually quite a complicated thing that's happened behind the scenes here. We can see that first there was a call to, what is this? There was a call to modelsinferenceai.com, and we can see that inside there, we can see various things about that call. We can see that it came back and it tried to do a call to get latitude, longitude. We can see that that then did another call to GPT-4o Mini, and we get access to all sorts of AI-related telemetry, like how many tokens we used and things like that. We can see it went on through various other stages and used different numbers of tokens. And if we go into the metrics view like this, we've now got various generative AI statistics, like the number of tokens that were used at different points in time. So all of that useful observability. Right, so that's all I wanted to show really about telemetry. I just think it's like a key part of building a sensible system. Okay,
Yeah.
shall we move on to MCP or anything else about that?
Let's do MCP.
All right,
Yeah.
so what's MCP? Dan, what is MCP?
Model Context Protocol. I know how to say the words, and I believe it's some sort of standard way for AI systems to like find available tools and resources that they can then use as a sort of discovery like system. I don't know, something like that.
That's right. It's a standard like plugin architecture for AI systems. So there's this spec that was created at Anthropic, one of the big AI companies, and they've provided a set of reference implementations of MCP servers, and these will plug in different bits of functionality into your AI application. And you can see they've got loads of different reference ones, and of course you can make your own ones as well. So you can expose all these different capabilities into your AI system. And there's just loads of them. I'm going to use one that will be quite familiar to everyone here. I'm going to use the GitHub one. All right. So I want to expose the ability to do GitHub related things. And you can see it provides all these different tools like creating files, pushing files, searching, creating repositories, things like that. Okay. Now, right now, this chatbot does not have access to any GitHub related stuff. So if I asked it a question like the following, what's issue 1000 and the .NET ASP.NET Core repo? Well, it's not going to know, right? It's going to try and do a search because we've provided a search feature, and it says like, no, sorry, I don't know. It didn't give me any information about that. So let's see if we can use this GitHub MCP server to provide the ability to access information from GitHub. All right. So what I need to do is add a client library that works with MCP servers, and there's one that's available called mcp.net. There's probably 2 or 3 different open source MCP client libraries, but I'm going to use this one called mcp.net. And then I am going to add a service that will make this available to my application. So I'm going to create a class called GitHub MCP service like this. Okay. And I am going to then just drop in an implementation that I prepared earlier, which is this. All right, so let me just add all the relevant namespaces, and then we'll look at the code. All right, I think this just about builds now. Good, that's looking good. All right, so what's all this stuff and how did I know to write this code? Well, if we look on the docs here and scroll right down to the bottom, you'll see it shows you an example of how this thing starts up. It starts up with this command npx and these other parameters, and basically you just translate that into the equivalent APIs for this mcp.net library, and you can see their docs for how to do that. It's kind of straightforward. Okay, and then I'm going to have this function called getToolsAsync, and that is going to look for all the functionality that's exposed by the server and convert them into a set of AI functions. An AI function is the abstraction representing functions from Microsoft Extensions AI. So just in the same way that I had a search function and I had a get weather function and a get latitude, longitude, and so on, I'm going to convert all these GitHub things into functions like that so we can plug them into our model. And that's really all there is to it. Now, in this case, I'm filtering it to use just these 2 tools, get issue and search users. Okay, so I've got this query that says only return those ones. I could expose all the GitHub capabilities at once, but it's kind of a bad idea to do that, because if you give your AI system access to too many tools, it tends to get a bit confused and use the wrong ones or use them at inappropriate times. So I'm just going to provide these 2 tools. Okay, so what I need to do now is expose that in my DI system. So I'm going to do builder.services.add singleton GitHub, what's it called? GitHub MCP service, like that. Okay, and then I'm going to inject that into my chat page, which is up here. Right, so using normal Blazor syntax, I'm going to @inject a GitHub MCP service, and I'll just give it the name GitHub MCP service, and then I can start using that. So what I'm going to do is I'm going to go to my onInitialized. I'm going to make this async because I'm going to need to make an async call to get the list of capabilities from that. So what I'm going to do is use this spread operator to say GitHub MCP service get tools async, like that. So that is going to, I need to await that because it's async. All right, so that's going to get all the tools that GitHub MCP service provides and make them available to my chat system. All right, so let's see if this actually works. I'm going to run now and wait for everything to come back up. So Spire is just restarting stuff now, and it's back up. All right, now let's try the same thing that I tried before. What's issue 1000 on the GitHub.net ASP.NET Core repo? And hopefully it will go and find an answer to that. It's actually not correct in this case. Let's just try that one more time because I'm not sure what it's doing there. All right, so it's actually done it. It's correctly connected this time. It says issue 1000 is this repository issue titled beta 8 web config exception. It's got all the information about it. And let's say give me, oh, it's actually got a link to it as well, even though it's not showing up in blue. I need to fix the CSS. And if I click that link, it should take us into the repo and it shows issue 1000. So it's correctly able to get stuff from GitHub now. And so I could also ask it other questions like, tell me about GitHub user Dan Roth. Remember, I add a search users feature on the list. Let's see what it does. Oh, look at that.
Oh my goodness.
There are several GitHub users called Dan Roth. Here are some of them. And the best one is right here at the top, look. Yay, the best Dan Roth. There are other Dan Roths, but this one is the best one. All right. So yeah, there are lots of them. Yeah. Would you like to know what I get Dan Roth's contributions? No, let's not talk about it.
Okay. So that was fast, and that was a lot. So that there you got an MCP server that can talk to GitHub.
Yep.
And you extracted its functions from it and surfaced them as AI functions in your Blazor application here. You used that like MCP factory API to do that. Was that like some glue code that you wrote? What was that thing? Like the
which one did you mean?
What back in your GitHub service?
Yeah.
That MCP client factory
yes.
API. That.
So the way that this MCP.NET library works is you provide it a specification for the server that you want it to work with. And that server might be something that's already running, or it might actually have to start up an instance of that server itself. Okay. And in this case, that's what it's doing.
MCP.NET library, and that's the MCP.NET library for doing that, for talking to that server. Okay.
Yeah.
And then you surface the API. So then this is kind of the foundations for like if you wanted to make your Blazor app somehow pluggable on the server somehow where you could like add MCP servers. I guess you could technically like have some system that like discovers them. Here you've like hardwired to just one.
Yeah.
Okay. That's cool. Makes sense.
I would say at the moment, the whole world of MCP is incredibly nascent. It's like this thing's only just been born and it can't really walk yet, and it's constantly throwing up. So like most things that you try to do with MCP will not work right now. The whole ecosystem is just completely chaotic. So I've cherry picked this one thing that actually works. I am sure that 1 or 2 months from now, it's going to be a much better situation. But right now it's like, don't expect too much of this. For example, the fact that the way that this works is creating a child process and communicating with it through a standard input-output. That's unbelievably inefficient and unscalable, and it doesn't even support multiple concurrent users. It's altogether an appalling system. So like so much about this is going to change very, very rapidly. But, in general, it's a very promising area that allows AI systems to, work with arbitrary capabilities. And I'm sure that within a matter of weeks, this whole ecosystem is going to move on and become, much better. But I just want people to understand if you go out and try and copy what I've done tomorrow, you'll probably find it fails.
Has some issues. Yeah. I think I saw like doesn't the latest Visual Studio Code Insiders version now have some level of MCP support for like plugging in MCP servers into it? Is that
probably yeah. So it's got the coding assistant Copilot, and it's very common to want to connect it to other sources of information, such as GitHub, or it could be access to other files on disk, or to like your own personal issue tracker or whatever. So it's like a general plugin system that it makes sense to be able to connect that.
Yeah. Okay. So I know some people in the chat were asking, like, is this MCP thing just hype? Is it for real? I don't remember where that question was, John, if you find it. But one way that I think resonates for me is, like, imagine you have something like GitHub Copilot in Visual Studio Code, and you want to sort of augment it with additional capabilities that could be provided by anyone, like, really. And the protocol abstraction creates that extensibility model, allows for that sort of plug-in model into your AI tool, whatever it may be.
Yeah, that's right. It's just web services with a sort of discovery layer and designed for AI. So it's nothing you couldn't have invented yourself. It's quite straightforward. It's just that there happens to be some sort of ecosystem developing around this particular spec that's starting to catch on.
Okay.
That was great. Thank you for that additional demo, Steve, and for staying on a little longer. A couple questions about the ingestion work that you showed. Like, you mentioned that the ingestion abstraction is just part of the template. It's not like a framework notion. Is there any effort to, like, try and create a set of, like, ingesters, plugin, like adapter things that know how to, like, grab data from a bunch of interesting sources? Is there any thoughts on that?
We are not really trying to create a general purpose data ingestion pipeline framework. Now, it's possible that this starting point here could end up developing into some sort of shared library framework type thing. We don't know yet. At the moment, we're just trying to keep it simple enough that when you create your project, you can understand the code that's in it and then change it and adapt it to your own scenarios. But honestly, I'd love it if the .NET if the open source community around .NET was to create some sort of data ingestion framework that was general purpose enough for people to reuse.
Cool. There was a question about WebNN, and like, I don't think none of this was using like the AI from, like, the browser itself. Like, WebNN, I think, is the web APIs for using, like, models from within the client on the client side. This is all server-based AI systems, correct? Is there any thoughts on WebNN and how it might relate here?
Well, in theory, and I haven't tried it, but I don't see why not. You could use Microsoft Extensions AI within a Blazor WebAssembly application and produce your own implementation of iChat client that works by calling through the WebNN APIs in JavaScript. And then you would have a chat client that works within the browser using whatever AI systems you can get hold of there. So if your browser has got a built-in language model API, then sure, you could use that. Or if you've got the ability to load a language model onto some, like, WebAssembly runtime and call that, you could. But it's not something I've tried.
Okay, yeah, so that's interesting. It's not something for someone to try. Maybe someone already has. I haven't actually searched around to see if someone's tried to do that JavaScript interop library themselves. There was a question about some of the chunking approaches about, well, it's more of a request to support other forms of splitting, I guess, like the text or token or semantic splitter.
Well, we absolutely support all possible things because it's just your own code and you can write any code you want to do anything.
Chunk it however you'd like.
Yep.
That makes sense. And then, is there anything else here? I thought I saw one. Oh yeah, the next level that Marvin was asking about is he would love to see a version of this that actually added authorization logic on top of I assume the vector store, where some of the data is only visible by some users and not by others. Seems like the system's, I mean, you could extend it to do that, but that would require a little bit more work just to make sure I guess the tools only can, when they ask for data, that they only get it for that particular user. Is that how you would model that? Yeah,
exactly. Yeah. So you've got we had a search async function, and you could use stuff from the current authentication context to provide other parameters with your search to limit the results according to who the current user is.
Makes sense. And then Andy wanted to know if the Microsoft Extensions AI library is still experimental, or if it's already at GA, and if not at GA, when's it going to ship?
It's in preview. We haven't announced a release date for it yet, so I'm not supposed to say, but it's not going to be long.
Soon.
Yeah.
Very soon. Cool. All right. Jon, anything else that you see from the questions that we want to pull in? You're muted, Jon.
I guess one other thing, like just kind of to wrap up with like, how can people keep up to date with this? Like, Marvin Klein was asking a question about like, where do I file an issue and that kind of thing. Like, it's on the .NET extensions GitHub repo, right?
It is, yeah.
Kind of...
That's right, .NET/extensions. Please do give us your feedback. We really do want to make stuff really work for real and not just in our demos. So we absolutely want that. And preferably give us your feedback really soon, because like I said, it's not going to be all that long before this stuff GAs. And if we want to get breaking changes in, maybe submit your issue like tomorrow or, as quickly as you can.
Okay.
Clock is ticking.
Yeah.
And then we did share at the very beginning of this, there's a blog post that went out a week and a half ago that shows how to install these templates and all that. So
that's right.
That's how you can get started. So you can try your templates today. What you just saw Steve do, the version that you showed us is something that's still coming a little bit later, right? Some of the features there, like the quadrant support, that's not been released publicly yet, correct? But an earlier version of the template at least is available for you to download and install and use, using .NET New or from Visual Studio.
Yeah, that's right. So I just took McKinnon's PR that he submitted last night and built it, and that's what I was using today. So theoretically, you could do that too, but you could also just wait a week and then, we'll ship an update that includes that.
Cool.
Awesome.
Yep. There's the link to the latest. I also shared it in the chat, and I'll make sure it's in the description. This is awesome. This is really fun. Like I said, I did my kind of, file new project, show it off kind of thing. It's great to see all the stuff you've extended and how to build on top of it. And then using those common interfaces, it's great to be able to say, hey, I could build against iChat client, against Olama or whatever locally, or I could go against, supersize it and go with, a big cloud hosting provider, et cetera. So very cool.
Well,
all right.
Thank you, Steve.
Thanks a bunch,
Thank you, everyone, for sticking it out with us and checking out the demos. Hopefully, we're excited to hear how it goes building your next AI-powered Blazor web app.
Awesome. All right. And with that, we'll wrap it up.
Bye. All right. Bye, everyone.